Okay, part 2. So solving E and natural log equations, these are going to be harder ones. Now most of these are quadratic equations in disguise, they just don't look like it. If we just look at that term there, something to a negative power, that's the same as 1 over e to the x. So this top equation, we've got 2 times some sort of exponential, we've got a constant term in the middle, and we've got this is 3 over e to the x. We don't really want to solve equations with anything on the bottom of the fractions. So our strategy here is let's multiply through everything by e to the x. So that first term is 2e to the 2x now, because we multiply by e to the x. This middle term becomes 5e to the x. And then this last one becomes plus 3. So all we've done is we multiply through by e to the x. If it was already on the bottom here, when we multiply through by e to the x, that will cancel out and we just get a constant there. Now this thing at the start, we can think of that as e to the x all squared. That's the same as e to the 2x. So this thing here is a quadratic equation. Now just like we did a couple of videos ago, you can substitute in a letter for e to the x if you want. I'm going to go straight for the factorization here. We want to have 2 brackets that multiply together to give that thing at the top. Well, we know it's going to be 2e to the x and e to the x because we need them to multiply together to give 2e to the 2x. We're looking for a plus 3 at the end, and so we know it's going to be 2 negatives because we're aiming for a negative in the middle. And our options here are 3 and 1. So if I go minus 3 and minus 1. Let's just multiply that out in our heads to make sure. That term times that term gives us that term there. That term times that term gives us minus 2 lots of e to the x. And then we've got another minus 3 of them from there, which gives us that bit in there. And then minus 1 times minus 3 gives us the plus 3. It's a quadratic equation, it just looks like something more complicated. Right, that solves to either e to the x equals 3 over 2, or e to the x equals 1. At that point, we can take logs of both sides of our equations. The log and the e cancel out, and so we get x is log of 3 over 2. Or, well, this one here, what value do we have to take e to the power of to get 1? It's going to be 0. You can think of it as log of 1 if you want and type it into your calculator. I'm going to leave those as exact. Right, here's one for you to have a go at. Pause the video. Your strategy here is multiply through by e to the x and try and get a quadratic equation. Pause it, have a go. Okay, let's have a go. So if I multiply through by e to the x, we get 8e to the x, or 2x, minus 2 lots of e to the x, and then that thing over there will equal 1. That's a quadratic equation. I'm going to take it all to one-sided. So 8e to the 2x minus 2 lots, this is the linear term in the middle, minus 1 equals 0. Factorising it, well, we've got some choices to make here. Oop, that's a 0. We need some sort of e to the x and some sort of e to the x. We need to pick the numbers that go in front of them. Let's try a 4 and a 2. It's going to be 1 and 1, and let's try and get our signs right. Negative, positive. So that multiplied by that gives us minus 4 lots, plus another 2 lots gives us the minus 2 in the middle. We're good. So either e to the x equals a negative a quarter, or e to the x equals a half. Right, this one I'll do first. If I take logs of both sides, we get x equals log of a half. Or, on this one, well, if you take log of a negative number, it will say math error on your calculator. This one has no solutions. Now, if you're looking at your calculator in confusion, and it's giving you a solution when you typed in this, but it's giving you negative log of 2, actually these are the same thing. Just a bit of justification on that. I'll do it in a second colour. A half, well, you can think of that as log of 2 to the negative 1, because a half is 1 over 2. but with log rules we can take the power out the front and it gives us that same thing there. So just in case you typed it into the calculator or Wolfram Alpha, these are the same thing, they're just different forms. Right, have a go at some of the hard ones from the exercise.